Yeah, good, awesome food. This has been great. I'm Alex Wise. My talk is called She's Gonna Blow. It's about when DevOps teams encounter or being asked to do more work than they can really perform in time, and strategies to maybe mitigate that or respond to that. But I gotta say, it's really cool to be on the DevOps stage, Rocky's stage. Like, this was one of my first tech conferences. I remember seeing J. Paul Reed give a talk, introduce me to like the snafu catchers report, and that kind of changed the direction of my career. So this is really cool for me to be up here. Really glad to be here. But yeah, this is my talk. This is what I'm going to be talking about, a little bit about me. You can find me on Twitter at AWS Snarkitect. I haven't really figured things out since the Twitter diaspora, so if there's a blue sky or a Mastodon or a cool signal group or something that is fun, let me know. I'm looking. I'm a software engineer focused in the reliability space. That's led me to a lot of cool companies, a lot of fun tech stacks, and some really incredible people I've gotten to work with. I believe strongly in open source software. I like to volunteer and teach for a local group called the Software Freedom School. We teach people how to use and why to choose open source software. So if that sounds interesting to you, ask me about it and what classes we have coming up. I work at a company called Bushel. We're a software company focused on the agriculture supply chain. We have customers like agribusinesses, grain elevators, and farmers. So if that sounds cool, I'll talk about ag tech with you. But everywhere I've been, that's my dog Clover. He loves responding to incidents, but only when the incident is dropping food on the floor. But yeah, I've worked a lot of places, seen a lot of things, and everywhere I go, I see teams in this state of overload. And it's not all the time, it ebbs and flows, but there are periods where a software team is being asked to perform more work in time than it can really accomplish. And it was kind of bugging me, like everywhere, why are we seeing this so many places? So definition there, that's the overload we're talking about, but really it's just being busy. So are y'all familiar with your teams being busy? Have y'all encountered this mode before? Yeah, I think it's pretty common. And it's also kind of dangerous if you stay in this mode for too long. Bad things can happen. This is from a very recent article about the CrowdStrike incident, and really just points to kind of the common production pressures and pressure to ship that we see at a lot of software companies. So being busy, it's very common. It's very important. So I wanted to kind of dig into why it happens and maybe ways we can make it better, ways we can avoid it or get out of that state of overload faster. So this talk is kind of my journey to understanding that. So start off talking about kind of why I think it happens, and then maybe ways to identify if your team is in that state of overload, and maybe some positive responses to it, and then a couple things that I think, behaviors that kind of exacerbate or contribute to staying in or being in the state of overload. So sound good? All right. So started where all quests for knowledge start in the modern age. I Googled it. You might say it's my search terms here, but it's Google. People are saying that Google search has gone downhill, so maybe it's that. But I didn't find anything on the internet, so I went to the library. I'm really bad at libraries. I tend to get distracted and like optimistically grab things off shelves and start reading. So I didn't find what I wanted in the library. So I thought, well, maybe if I can't find my answers out in the world, maybe it's in self-reflection and meditation that I will find answers. So luckily, we got a bunch of mountains around here. So I hiked up one and said, I'm going to sit and think, and I'm not going to come down until I think I have an answer and understanding why teams, our software teams, seem to spend time in this state of overload so frequently. And I did that. So I came down thinking I really understood two things about the universe. One, our resources, our time, attention, and energy are finite. And the other is that the world is constantly changing, and we're having to respond to that change. Then I realized I didn't need to climb a mountain at all, because this is Dave Woods. This is the adaptive universe, the theory of graceful extensibility. And it's true, right? I think Dave Woods must have climbed this mountain. Is how we got to these answers. But if you believe that resources are finite and that the world is constantly changing, we would expect that ourselves and the systems we're a part of are constantly having to adapt, and as we adapt, we're bumping up against these time pressures, these cost pressures, these resource pressures. And I wanted to lead the talk off with this because when we talk about incidents, we talk about technical debt and things like the CrowdStrike outage, you sometimes get a chorus of things like, real engineers would never ship code with no tests. It's like no true Scotsman thing, or that team made their bed and they're sleeping in it, or it was the greedy business. They were intentionally withholding reinvestment to make money. And the thing is, none of these need to be true for a team to find itself in this state of overload, to be making very difficult trade-off decisions. So really, first and foremost, I think have empathy for teams feeling it, because we're all going to be there someday. It's just the natural fact of the adaptive universe. But it's also important that we be efficient with our resources. That way, when we are adapting to the universe around us, we don't bump up against these resource limits. So yeah, that's kind of why I think, that's where I came to with kind of why we find ourselves in this state of overload. But things regularly feel hard, and I'm constantly uncertain. So how do I know if the pain that I'm feeling is because of this state of overload? Maybe it's a different thing with different causes. And the thing is, Dave Woods has us covered there too. This is the Joint Cognitive Systems book. It's kind of the applied case study companion to their cognitive systems engineering book. If you're familiar with the SRE book and the SRE workbook, this is kind of that workbook. And in it, Woods and Hollnagel lay out a framework for understanding how systems, when they're asked to perform more work than they can do, they really only have 4 options. So they can shed load, they can reduce thoroughness, they can shift work in time, and they can recruit resources. And as a rule of thumb, that recruit resources and shift work in time, those last 2, those tend to yield better outcomes than the first 2. But they do require anticipation, they do require planning, and they require a cost and resources to do them. So I love this framework. This framework's very cool. I like it particularly in incident interviews. So if you're in an incident review and you hear something like, at that point the server was dropping requests on the ground, or our database had dirty writes, it might perk your ears and you might think, okay, so is there a way that we can adapt this system from these reactive responses to overload? Maybe we build in back pressure, or we set up auto scaling, and we move to these more anticipatory, usually more positive responses to overload. But the joint and joint cognitive system, that means any system where humans and machines are working in concert. So this framework is equally true of your software team and their Jira backlog, their work management backlog. So it applies there too. So if you hear quotes like this on your team, it might be a one-off thing, but if you start to hear a pattern, you hear them over and over again, it could be a response to overload. Things like, did anyone fix this? Or, do you know why this never got done? Or, oh, it looks like this change never got committed. That could be responses to overload manifesting on your team. But I think it's also important to celebrate when we respond to overload in those more anticipatory, planning-based ways. So things like, we saw we weren't going to be able to get this done, so we got it shifted to next quarter. Or, hey, we're kind of busy with this other stuff right now. Can this team do it? That's a win. Those are successes. That's your system responding in the most positive way to overload. So Dave Woods really had us covered for the first 2. I'm kind of a one-trick pony there, but gave us a map as to understand kind of why we find ourselves in this state of overload so often, but also not just how to diagnose it, but ways to get a more positive response out of it. But I still didn't feel like I had a handle on what was on causes or contributors. I wanted to know if there were things that I was doing, or that my team was doing, or that my organization was doing that was causing us to end up in this state of overload more frequently. So I'm an engineer nominally. I thought maybe I'd do some math about it. So I did. I set up a little simulation, just a few assumptions, kind of modeling what I know about software. So we're going to model just like a single service. It's going to have 4 engineers writing the code. They're going to write 150,000 lines in the first year, and then they're going to stop. We're not going to touch it. We're not going to write any more code, add more features after that. We are going to model attrition, though. We're going to say every year, the employee with the longest tenure gets replaced. And then each year, we're going to say we find bugs. For however big the code base is, we're going to find bugs that we need to fix and update those lines of code. If the author of that line is still at the company, we're going to say it takes an hour to fix. If the author's not, it's going to take 10 hours. These numbers kind of pulled out of my hat. I'm not trying to get to an actual number of hours here. I'm just trying to see the shape of the curve and kind of what are the forces at play. And the thing we're going to measure is the hours that you spend in the year debugging this service. So what does that curve look like? Well, looks a little like this. So over here on the left, man, we're cruising like 1,500 hours a year that we're just spending doing bugs. Not too bad. Going real fast. We're writing bugs, but we have such full context of the system that we can fix them quickly and things feel good. Over here, we tend to plateau. We don't know much about the code base anymore. All the original authors have left, and things are slow, but at least they're predictable year over year. This part in the middle, where the same amount of work takes longer each year as we lose knowledge about the code, this is a strong contributor to that feeling of overload. This is where we're bumping up against those finite resources, the time pressure, the effort, the attention pressure that Dave was just talking about there. And it's really not a great model. We don't have unbounded hours to spend fixing 150,000 line service. So, what if we say, actually, we're not willing to spend more than 1,500 lines or 1,500 hours a year on this? Well, the number of bugs you fix drops, and your backlog grows monotonically forever. So this is also, if you're seeing this on your team, could be a response to that. I like to call this knowledge decay. I don't know if it has a fancy name. If it does, shout it out, tell me later. I bet someone has done some thinking on this before. But the idea is that our understanding of our systems degrades, and it takes us longer, and it's more expensive for us to adapt. So that's what it is, but what can we do about it? Well, when this comes up, usually there's a pretty quick tautological answer that is just, well, retain your employees, right? If people don't leave, then you won't have this problem. And that's very true, right? Retaining your employees is a superpower, absolutely. And do whatever you can to do that, but it's not always possible. The folks who love the ride from 0 to 1 rarely like that ride from 1 to 2. There may not be room at your org on your ladder for anyone who wants to be promoted above senior engineer to do so. So really, you need to build resilience to the impact of folks leaving, and I think that's also a superpower. So retain your employees however you can, but what else can we do about it? Well, in this model, there was kind of this implicit assumption. So at the start of it, we said 150,000 lines of code, and we split that up evenly, 37,000 lines apiece among the 4 engineers. But that doesn't necessarily have to be true, right? We have tools like pair programming that let us share knowledge as we write it, right? So what happens if we were to pair program on this service? Well, that looks a lot better to me, right? I'd rather be in the find out stage down here than the find out stage up here. It gives us a lot of benefit. I will say that all of the benefit is focused on that initial 150,000 lines of code. Over here, when we're not really touching the code anymore, this is 1,500 lines a year of bug fixes we're doing. Pair programming doesn't really have a benefit there. But over here, this is where you get real value. But that also raises another point, right? What if we did touch the code more? What if, over here, we said, we're going to rewrite half the code base. We're going to migrate things over and refresh this code base. What does that look like? Well, that buys us a ton of good. We've now halved the amount of time it takes us to fix bugs. We've renewed our understanding so that we're resilient to losing folks in the future. And this graph here, when I got to that triggered a memory for me. I'd seen something like that before. So this is a graph from Will Larson's blog. Will Larson is currently the CTO of Carta. He's got a really good blog down there in the corner. This post is called "Migrations: The Sole Scalable Fix to Tech Debt," he makes the case that what you want to do in your organization is to actively seek out and find targets to update and refresh your code base. And really, that is the only way you're going to manage your code base and keep them becoming brittle, keep them from becoming stale, and renew knowledge about them. So yeah, what he's really saying there is that migration is a set of muscles that you should be actively building in your organizations. Things like identifying good targets for migration or recollecting requirements. So stop asking, hey, why does this service work the way it does? And start asking, if we were to rebuild this service tomorrow, what would it need to do? That's a much better question to ask. Driving technical change, building consensus. This is your classic principal engineer stuff. Get everyone on the same page about what work needs to be done. De-risking migrations. Can you make them smaller? Can you make them go faster? Can we do them in stages? I promise if you have a big migration go sideways, you're going to be migrating far less than you want or need to in the future. And finally, probably the most important, sell that change to the business. If we have an MS SQL server that's working, but we don't really know how it works and it's getting kind of long in the tooth, why should the business reinvest in replacing that? What is the benefit there? So getting good at making that case for why this needs to be updated, you'll be in a much better place. So that's migration. That's kind of one approach to fighting knowledge decay, probably the sole scalable approach to fighting knowledge decay. But I do want to say one more thing about knowledge decay. I'm going to call this "you touch it, you own it"ism. People on the internet might have heard it as the Copenhagen culpability principle or the Copenhagen theory of ethics, but I don't know what that means. So you touch it, you own it-ism. Basically, in an organization that's fighting knowledge decay, struggling with the loss of knowledge of their systems, there tends to be a response where people, if you touch a thing and it later breaks or causes a problem or becomes brittle, you bear responsibility. You own that thing because you touched it. So there's this hesitance to touch the unfamiliar parts of your code because you don't want to become the new owner of them. If you see that, fight that. If you're an engineering manager, you just make sure you're shouting out and rewarding and encouraging, diving into and understanding these neglected systems. Do lunch and learns about them. Kind of share that knowledge out so that everyone's touching it and everyone owns that piece of it. If you're a principal engineer, like a solver-style principal engineer, just dive in head first, take a junior engineer with you, and build yourself back up and build your understanding and document that. Principal engineers also on the hook for all of these really hard things, unenviable things about migrations. So cool, knowledge decay. That's what I have to say about that. Getting better at employee retention, retain your employees however you can. That's going to look different for every company. Whatever your comparative advantage is, do that. Mobbing and pairing and sharing at the time of writing code. So you can't do this retroactively. Once the code has been written, it's very hard to distribute knowledge about it. Migrating, proactively migrating stuff in your code base. And then that you touch it, you own it. Really try to root that out and make sure that that's not happening in your org. So I thought I had some answers there, but making all those graphs and talking about JIRA backlog lengths reminded me of a book that someone had lent me 5-6 years ago at this point. So I never gave it back. I'm sorry. Thanks for the book. But the book is Flow by Don Reinertsen. And Don Reinertsen, I guess I'll call him a systems thinker. He's one of those guys that applied lean manufacturing principles to software development. And he did it using a lot of Q theory, mathematics, things like Little's Law. And he modeled software delivery teams, like a DevOps team, as a mathematical queue. Work arrives somewhat randomly. It gets completed in kind of a distribution where most stuff is completed quickly, but some stuff has a long tail. And that was kind of his frame of reference for work entering and leaving DevOps teams, and then draws assumptions about it. And he has a lot of really good insights in the book, I think. I'd recommend it. It's pretty readable. But the two that are salient for this talk, don't saturate capacity and batch size matters. So Don Reinertsen has a lot of opinions about overload as well. For him, when you model a DevOps team like this mathematical queue, these kind of queues have a specific property where if you try to give them all of the work that they could possibly handle, they tend to lock up. So as you go from about the sweet spot's about 75% utilization and go above that, you start seeing throughput tank pretty quickly. And you start seeing variability increase. So like work that you would expect to take an afternoon might suddenly take a week solely because you're more busy and things are taking longer and there's not really a clear reason why. So for Reinertsen, try to avoid overload, not just because it might cause outages, it might make you make hard safety trade-offs, but also because it's just poor economics. And because this is a DevOps conference, DevOps teams tend to be more interrupt-driven. So as you're planning work, you really want to try to shoot for about 75% utilization of your team when you're planning for a sprint or a quarter or whatever. There's a high cost to being overly optimistic about what you can get done. And if 50% of your work is going to be interrupt work, fixing CI pipelines, supporting delivery teams, patching, maintenance, incident response, you really only want to pull in about 25% of what you think you might be able to get done because that interrupt work is going to come first. But if Don Reinertsen hates overutilized teams, he hates large batches even more. So if you see, let's say, a ticket hit your work board, we need to migrate such and such database. Well, that's actually multiple environments, multiple databases, multiple downstream consumers. That's actually kind of a big, hairy thing, right? So if you do work in those large batches like that, your cycle time goes way up. Your variability that we talked about before, things take longer for no real reason, that goes up. But also these large batches tend to be self-propagating and self-reinforcing because if you've got like one big ticket over here, if it's got dependencies, if things are dependent on it, then they need to become big tickets, and then they need, it just sort of spirals and chains out throughout your environment. So break down work. If you see a big nebulous ticket hit your board, develop the instinct to swarm on it and carve it up into small pieces. I often, for agile folks, this is basically refinement. So this is kind of rote. But a lot of folks I see when they're encountering overload, one of the first things they do is they get rid of shared process meetings. They're saying we're spending too much time in meetings. We need more heads down work. Let's kill our refinement, and we'll use that extra 2 hours to actually get the work done. That tends to be the wrong direction, I think. The benefits of carving up big work into small work when you need to is definitely worth the time it takes to do it. And it can be done by a single engineer, right? You don't need to wait for consensus for the team. If you say, oh, I think this is actually 6 environments, let's do a ticket for each environment, and you'll have a much better time with that ticket. The other thing that Reinertsen talks about is WIP limits as a tool for kind of controlling, managing workflow on your team and keeping throughput high. There are a lot of different philosophies on that. I'm not like a strong advocate of any one way to do WIP limits. But there's a lot of agreement that they do help tremendously in sort of prevent or keep you from going into the sort of the bad cases where you've got work is getting stuck and service times are getting very, very long. So, whatever works for your team, maybe setting some kind of a limit to the amount of work in progress that you can do will help improve this feeling of overload. But there's also organizational level WIP. This is kind of like for your specific team. Can you set a WIP on the queue? But organizationally, I think high work in progress has an impact as well, one level up. And this is a diagram by John Cutler. I love this diagram. I have it as a Zoom background whenever I want to throw shade. But the way you read this is like this. So you see that the work in progress is increasing in your organization. We've announced yet another new initiative. And so because we've got more work coming in, it creates more dependencies on other things. Then we have to hire coordinators to work out through those dependencies, and that means we have to do more upfront planning. And it all sort of feeds back around and eventually gets back to WIP, and it's kind of a self-reinforcing thing. One thing I really love about this visualization of it is you can imagine some really good interventions here, right? So like if you've got a really good manager, they might protect their team from that pressure for short-term results and try to circuit break here. Or if you're an engineer, you might do some hero work and stay up all night and make sure you deliver in a timely fashion. But if you don't address the rising work in progress, you will see it will find other ways through the system, and it will still be self-reinforcing. So those sort of individual heroic interventions are only have limited effect. Yeah, but also we can kind of see here, well, cutting corners, that's a little bit like reducing thoroughness, and over here, can't really see it on the slide here, but recruiting resources, shifting work in time, shedding load. So a lot of our responses in the organization to high WIP are also our responses to overload. So we may want to try to lean toward our more positive planning-based responses. So queues, cut out the aspirational backlog. Don't pull in stuff that you don't think you can get done. Don't leave stuff around just to remember that you need to do it. Like your Jira queue is not the place for you to leave the reminder that you want to try out this new tool. Find a different place for that. And try to only pull in about 75% of what you think you can get done. Carve up big tasks. Don't let those big things stay in big block form. You will get so much value out of carving it up. If stuff does seem to be going long, if a ticket is taking for no real reason longer than you think it should, just develop the instinct to swarm on that and tackle those P99s. And then WIP limits, whatever works for your team there, you can do that. So that is what I've got. Can do a Q&A, anything. It was a kind of a dense thing, but thank you.